Okay, we're going to have a quick look at how to solve algebraic equations using one and two step processes. The way we do it is exactly the same as the name suggests. It's literally about how many steps it's going to take to solve it. So let's have a look at an example. If we had something like this, 2x equals 10, okay? Now we can probably work this out just instinctively, but let's look at how to do it correctly. So what we want to remember here is 2x is really the same as saying 2 times x, right? And that's, of course, equal to 10 still at the moment. Now, to solve this using one step, and I'll explain why it's one in a second, we're basically looking at moving something from one side of the equation to the other side with the intention of getting our x value, our variable, our pronumeral, all by itself, so we can actually end up with an answer. Now, what we want to do is we basically want to undo the steps that have been done. So at the moment, this equation is saying 2x is equal to 10. So we have to 2 times whatever the x value is going to be equal to 10. All right, so to find out what x is, we need to undo this left-hand side. And we do that by basically taking one operation at a time across to the right-hand side. And to do that, you basically do the opposite. So let's look at this line here. So at the moment, this here, this second line, is 2 times the x. So to take that 2 times across to the right-hand side, we need to do the opposite. So we're essentially going to divide this side by 2. So I'm going to use a red pen here to just indicate that I'm dividing this side by 2. So that means I need to do the same to the other side. Okay, the divide by 2 on the left-hand side essentially has the effect of cancelling this out. So we end up with just the x being left on this side. And of course, on the right-hand side, 10 divided by 2 becomes 5. So we have our x value now that we know is equal to 5. And we should always double check our work. So let's substitute in the value that we think. So we think x is 5 from our working out. So we say if x equals 5 in this equation, 2x equals 10, is that correct? So put the 5 in, right, and then do the math. So 2 times 5 is, of course, 10 equals 10. Does 10 in fact equal 10? Is the left-hand side equivalent or equal to the right-hand side? Yes, it is. So we have proven that we solved it. So let's go back up the top for a second. What actually happened here again? So again, in this line here, we had 2 times x. To undo the 2 times, or the multiplication of 2, you have to do the opposite. And the opposite, of course, of multiplication is division. So we did division on both sides of this. Again, the division on the left-hand side had the effect of getting rid of this 2 times. And of course, division on the right-hand side, because that was just a whole number, gave us the number 5 at the end. So this was a one-step process. So to go from here to the answer, it took one step. We had to undo one operation. And that is what we refer to as a one-step equation. So what about if we have a slightly bigger equation? So let's have something a little bit similar. 2x plus 5 is equal to 15. Okay? Now, we can see there are 2 operations happening here. So again, technically speaking, this is 2 times x, and that first multiplication is our first operation, plus a 5 that we have here, and that's equal to the number 15. So we can say that there are 2 operations here, 1 being this multiplication, and 2 being this addition. So we can see that this is going to be a 2-step process to solve this equation for the value of x. So we want to undo the steps that we're doing on the left-hand side. And again, we think about our bid maths or our bod maths, and we basically do it in reverse. So normally, if we were trying to do this equation, we would do our multiplication first, the 2 times x, before we did the plus 5. So because we're going in reverse, we're going to do the plus 5 first. So our step will be to try and get rid of this plus 5. We're going to take 5 on this side, which means we have to take 5 on that side. Okay, so to write this out really accurately, what we should do is 2x plus 5, which is what we already have, and I suggest you use a separate colour to do minus 5, you can see that's taking away from itself, equals 15 minus 5. Again, suggest you use another colour, so you can clearly see the steps that you're doing. So we now have 2x plus 5 minus 5, of course, is cancelling itself out, equals 15 minus 5, of course, is 10. Now, we've actually ended up with the same equation that we had in the first example, but now we're going to do our second step. So again, remember 2x is really the same as 2 times x. So if I'm going to write this out, I'm going to go 2x. Now, to do it in the right format, I'm going to do this divided by 2 because we're trying to cancel out this multiplication of 2. And on the right-hand side, I'm going to do 10 over 2. Again, we do the fractional format because we want to show anything with algebra, preferably as a fractional format if we're doing division. So 2 times 2, so again, we can cancel those out, so we just end up with x, and 10 over 2, looking for common values, we know it's going to end up being 5. So we can see we had one step here, and we had a second step here to solve for that value of x. And again, we want to prove this to ourselves, so we'll just do here is if x equals 5 into x plus 5 equals 15, substitute the value of x into 5 plus 5 equals 15. 2 times 5, of course, is 10, plus the 5 is still equal to 15, and 10 plus 5 being 15 is equal to 15. I can't draw an accident. There we go, 15. And of course, 15 is the same as 15, so it is true. We can prove that to ourselves. So it's just about working out the order that you would do the equation and then basically doing it in the opposite direction. And of course, to cancel one out on one side, we do the opposite of that equation, that operation on the other side. So pluses, of course, become subtractions, multiplications become divisions, of course divisions become multiplications, and subtractions become additions. So we just do the opposite equation, opposite operation to move it from one side to the other. So let's have a look at another example. Let's say we have x divided by 2 is equal to 10. Okay, so we can see there's one operation being done here on the left-hand side, and that is a division. So this is going to be a one-step process. And we know that if we have a division, it becomes a multiplication to move it across. So let's write it out properly. We're going to have x divided by 2, then using another colour multiplied by 2, and that is going to be equal to the 10 that we have on this side, also multiplied by 2. So this divided by 2 is cancelling out with this multiplied by 2. So of course we end up with x being equal to 10 divided by 2, 10 multiplied by 2, which of course is 20. We should always check it. So if x is equal to 20 in the equation x over 2 equals 10, substitute the value in, so 20 over 2 equals 10. 20 over 2, of course, is 10 equal 10. Is that the same? Yes, it is. So we have proven that one as well. Okay, here we have another example. 3 plus x over 2 equal to 13. So here, again, if we look carefully, we can see two operations. First, we have an addition, and we also have a division. So we know this is going to be a two-step process. And we want to think about the order that we do these, which is going to be the reverse of how we would normally solve it. So we would normally do our division, and then we'd do our addition. So to do that in the reverse order, we're going to try and fix up or get rid of the addition, and then do our division next. Okay, so let's have a look at this. Now, the first thing I want for us to remember is that 3 plus x over 2 can be written the other way. We could also write x over 2 plus 3. And it's still plus 3 because remember, technically there's a positive in front of this 3. We don't need to show it because it's a number by itself in the front, but it's technically still there. So we can rewrite this addition in this way. And the reason you might like to rewrite it is it might make the equation clearer for you, that we're going to get rid of this plus 3 first and then deal with the x divided by 2. You don't have to, of course, and this doesn't count as one of the steps, but you might find it more convenient to have the equation in that order. It doesn't always work, of course. So if we had 3 takeaway, we would have to think carefully about the pluses and the minuses, the positives and the negatives as we move things around. So it may or may not help you, but let's go with it. So the first thing I'm going to do is rewrite this equation with my first step. So x over 2 plus 3, and I need to do the opposite of that plus 3 to get rid of it. So I'm going to do take away 3. And that's going to be equal to 13, also take away 3. So doing the same thing on both sides of the equation. That, of course, has the effect of getting rid of that. If you add something and then take it away again, it's effectively 0. So we have x over 2 being equal to 13 divided by 3. Sorry, 13 take away 3, of course, is 10. So now we have to get rid of this divided by 2. So we've got x over 2, and then we're going to have times 2. And that's going to be now equal to 10, also multiplied by 2. So again, to get rid of this division by 2, we're getting a multiplied by 2. So we now have this being x, because of course that divided by 2 and that multiplied by 2 cancel each other out. So x is now equal to 10 times 2 being 20. Again, we should always check. So if x is equal to 20, 3 plus x over 2 is equal to 13. Let's substitute in our 20. So 3 plus 20 over 2 equals 13. We will do our division first. So 3 plus 20 over 2, of course, is 10, is equal to 13. And 3 plus 10 is 13, being equal to 13. Yes, it is. So, of course, that is correct. Okay, let's have a look at one more example. Again, we can see that this is going to be a 2-step because we have 2 operations, an addition and a division. What's different about this one is that we seem to have the whole number, or what we might think of as our answer, on the left-hand side, and the equation part, the part with the algebra in it, on the right-hand side. And it doesn't make any difference whatsoever. My personal preference is to have the algebra on the left-hand side and to have the answer, so to speak, on the right. It does not make any difference whatsoever, but I am going to rewrite it just so that I feel more comfortable. Again, this may or may not be something you like to do, and it doesn't count as one of the steps of solving this, of course, but I personally like to rewrite it. So I'm just going to do x over 3 plus 10 is equal to 20. And again, all I have done at this point is rewrite the equation, so I have the algebra on the left and the answer on the right. Makes no difference. So to solve this, of course, we're going to undo the equations, or the operation, sorry. So I'm going to get rid of this plus 10 first. So to do that, I'm going to have to do a takeaway 10. So I have x over 3 plus 10, and of course, in my other colour, I'm going to do minus 10, and then that is going to be equal to 20, also minus 10. We do that bit of math, so this plus 10 and minus 10 cancel each other out, so we end up with x over 3 being equal to 20 minus 10 being 10. So again, x divided by 3 is equal to 10. To undo, or to undo the divide by 3, we need to now multiply by 3. So we're going to have x over 3 multiplied by 3 being equal to 10 multiplied by 3. So again, doing the opposite operation of division, they cancel each other out, so we end up with x being equal to 30. Always check, so if x equals 30 in the equation of, and I'll put it back the original way, which is 20 equals x over 3 plus 10. So we will have 20 being equal to, let's put the value of x in, 30 divided by 3 plus 10. 20 being equal to 30 divided by 3 being 10 plus 10, and then 20 being equal to 10 plus 10 being 20. Are they equal? Yes, they are, so that is now solved. So that is the basic idea of solving an algebraic equation by using one or two step process. Of course, you can have more than two steps. The questions that you're going to be asked to do generally won't have more than two steps in them, but the process would be the same. Look at how you would normally solve the equation, then do them in the reverse order. So think about your BIDMAS, but do it in reverse. And then when you need to move part of the equation from one side to the other, you do that by doing the opposite of that operation. So again, pluses become minuses, minuses become pluses, divisions become multiplications, and multiplications become divisions. And that is again sort of the key to what we need to do. You do the operations in reverse order, and you do the opposite operation to essentially cancel it out. So have a go. You can come back and obviously relook at these particular examples and see how you go with your questions. I would like to see it set out in such a way so you can see how I did the multiple colours, how I rewrote the equations. These are steps that I'm particularly interested in, so I can see where I've written out the equation and shown what I'm going to do to cancel it out. And again, this one here, these are the parts that show your understanding. But again, don't jump steps. Don't try and do multiple things at once. Do one step at a time and show all of your working out.